Very good afternoon to one and all. And today concept is about code optimization, where it is in fifth unit. It is as per the syllabus. It is not in the fifth unit. It is in the last unit. The concept code optimization is in the last unit. And here, where the code optimization is the next phase of the intermediate code generation. That means the first is an lexical analyzer, the second is an syntax analyzer, and the third one is an semantic, and the fourth is an intermediate code generator, and the fifth is an code optimization. And here we are going to learn about the fifth phase of the compilation, that is code optimization. First, initially, we need to know what is a code optimization. What is an code optimization? And here we are having a slide for that. What is an code optimization? And while coming to the parts of the compilers, there we're having two parts, right? One is an analysis part and another one is a synthesis part. Analysis part consisting of three phases: lexical, syntax, and semantic. And coming to the synthesis phase, it consisting of two phases: code optimization and code generation, where the intermediate code generation is the mediator between these two parts, right? Just I'm recalling the parts of the compilers. And here the code optimization is in the synthesis phase. And what we're doing here, how we're going to implement this code optimization phase means, this optimization is required to produce an efficient target code. For getting the efficient target code, for generating the efficient target code, we are using this optimization techniques. We're applying some transformations. That optimization technique transformations here. And there are most important two issues under the code optimization. That means these two important issues that need to be considered while applying the techniques for code optimization. And before knowing what the issues are, what the two most important issues are, then first initially we need to know what is optimization, what is code optimization. Here we're having a definition, what is the code optimization in the slide itself. And it is a program transformation technique, and which tries to improve the intermediate code by making it consume fewer resources, so that faster running machine code will result. And by doing an optimization, what type of a result we are getting means, we are getting the faster running machine code, because there we implement an optimization, right? There we implement an optimization. For example, we're having CPU as an example and memory as an example. Considering those two examples, and here I defined what the code optimization is. And now going to what the issues, most important issues of this code optimization is. The first one is a semantic equivalence. The first issue is a semantic equivalence. What the issue of this semantic equivalence is, the semantic equivalence of the source program must not be changed. Make a note of this. The semantic equivalence of the source program must not be changed. And what the second issue to be considered while applying the techniques for the code optimization. The second issue is the improvement of the program efficiency must be achieved. And how we are going to achieve this is without changing the algorithm of the program. Make a note of this. Without changing the algorithm, without changing the meaning of the program, we can say that, or without changing the algorithm of the program, we need to improve the program efficiency. We need to achieve that efficiency just by improving over the program. These are the two most important issues that we need to consider here when we are applying the transformation techniques under the code optimization phase, right? What it means is, here we are implementing some techniques. That means we are applying some techniques. While applying such type of techniques, what I will explain in the further classes. And while applying such type of techniques here, these are the two most important issues that we need to consider. One is a semantic equivalence. The second one is an efficiency of the program. And then what will happen is, if the code becomes an inefficient, now we're only talking about the efficient. Why? Because whatever the target code that we are going to generate, it should be an efficient code, right? So just assume that if the code becomes inefficient because of two factors. What those factors are? One is programmer and the other factor is a compiler. These are the two constraints. These are the two factors that show those are the reasons of when the code becomes an inefficient, right? Now we're only trying for getting an efficient code. For example, if the code becomes an inefficient, Then on what basis the code becomes an inefficient means there are only two factors that we need to consider. One is the programmer and other factor is the compiler, right? And here in this code optimization in this unit, this is the half of the unit of the last sixth unit. Our sixth unit consisting of an code generation as per the syllabus, and the concepts under the code generation, and along with those concepts we're having the concept like in code optimization, right? This is not an individual 15 unit as per our syllabus. This is the this code optimization concepts is under the sixth unit. Once if you refer the syllabus, then you can see in the sixth unit the concept of code optimization at sixth unit, not in fifth unit, right? Half of the sixth unit is about the code optimization and the remaining half is about the code generation. But I'm explaining and each and every unit by unit just by comparing with an process of compilation. What it means is what the phase number one is lexical analyzer. So starting with the lexical analyzer, what the phase number two syntax analyzer, and there the second and the third unit comes under the syntax analysis, right? And the next is about the semantic. In the third, I explain about the semantic. And fourth phase is an intermediate code generator. Here in the unit number 4, I discussed about the intermediate code generator, right? And as per our process of compilation phases, the fifth one is an code optimization. But here, while comparing this phase, this number, the phase number with an unit number that comes under the sixth unit, it is at the half unit in sixth, right? And now, what I'm going to discuss in this chapter is in this concept under the code optimization is here. I will discuss about the various transformations that could be applied on the code to improve the performance of the program, and and other topics are about what the types of transformation techniques that are in a code optimization, right? And I will discuss these concepts under the code optimization. And here, after code optimization, the last phase is code generation. Yes, after the code optimization, what we are going to generate, we are going to implement the last phase that is in code generation. So here we need to know exactly how the code optimization techniques can be applied, and where exactly code optimization techniques can be applied. We need to know those things. So it is the responsibility here. It is the responsibility of both the programmer and the compiler to generate the efficient code. Make a note of this. That means using proper usage of the target code. And if the code was inefficient, then automatically we're considering mainly two factors are programmer and the compiler, right? So if the code to get the code and in an efficient way, to get the code to generate the code in an efficient way, whose responsibility is only the programmer and the compiler. These are the two both persons having the responsibility. Persons in the sense compiler, who is doing the compilation, who is compiling it, and who writes the code, who are writing the compilers. And for why we are doing all this, the simple answer is to generate the efficient code using proper usage of target code, right? And here once all of you see the slide, after knowing the definition and after knowing why we are learning this code optimization, and then we are learning about compiler optimizing process should meet the following objectives. What the objectives here? If I want to optimize the code, then what the objectives that I need to follow up here? The first one is the optimization must be correct. It must not in a way change the meaning of the program. This is the most important thing. Wherever you are optimizing, wherever you are applying the optimization techniques, one thing you need to uh, consider it as a main objective is you should not change the meaning of the program. Meaning of after optimization also, whatever the program before optimization, whatever the meaning it is having, then after the optimization also the program should have that meaning. So meaning should not be changed, right? And when we are performing these optimization techniques, when we are applying the optimization techniques, what will happen? what will happen? What will happen in the sense, here we need to consider mainly two things. One is speed, right? One is speed, and in that speed, always the speed should be increases. Always the speed should be increases. That impacts the running, machine running. See here, I'm having the point here at the definition. At the definition, why to optimize this? What is the definition of optimization? Means by improving the intermediate code by making it consume fewer resources. Though what the resources are as CPU and memory, these are the some examples of the resources. So what will happen, what the resultant will be is faster running machine code will result, right? So here also two things, two most important terms we need to always remember. One is speed and another one is in time. One is speed and another one is in time. Always the speed should be increased. Optimization should increase the speed and the performance of the program, and the compilation time must be kept reasonable. Make sure that the compilation time must be kept reasonable. And finally, the optimization process should not delay the overall compiling process. These are the main objectives we need to follow when we are performing an or applying the optimization techniques to the program, right? Or lines of code, whatever it may be, to the compiling code, right? So these are the most important objectives. So please consider these most important objectives, follow these most important objectives, and always when we are applying that, when we are performing something to optimize, then you need to make clear of all those. That means you need to remember all these objectives. First thing, without changing the meaning. Second, increase the speed, increase the performance of the program. And third one is an always the time must be an reasonable, compilation time must be kept reasonable. And finally, the overall compiling process should not be delayed when we are performing the optimization, right? These are some of the objectives of this. We need to follow these objectives. And when to optimize, we know what is an optimization. We know what is an optimization. Then here we're having a question that when to optimize. When to optimize. And in a simple single line sentence, how I can define the optimization is just improving the efficiency of the code. Just improving the efficiency of the code just by minimizing the lines of the code. By minimizing the lines of the code, what we're doing here is, here I'm improving the efficiency of the code, right? What is code optimization? Here we're optimizing some amount of code. We're optimizing, that means we're applying the techniques at some amount of code, right? So there we're performing some modifications and we're updating that code, and finally we're generating an output. And that output should not be changed the meaning of the program code, right? This is the most important thing. In such a way, I can define what is code optimization means, right? And here, when to optimize, I know, up to now, I know from the starting of this class by by getting some knowledge about what is code optimization and what is the need of using this code optimization, and then what are the objectives of code optimization. Now I'm going to learn about when to optimize this. Just by knowing some knowledge about this code optimization, now I can define that. I can give the answer about when to optimize. When to optimize. When to optimize. When it is necessary to optimize. At each and every phase, we're performing the optimization, but we're not showing there. We're not talking about that, because phase by phase level itself, there itself, we need to improve the efficiency. We need to increase the efficiency of the code. Then only the target code should be an efficient code. Then only whatever the target code we're generating, it should be in an efficient way, right? So here, what the question I'm having here is when to optimize. So the meaningful question, because after knowing the definition of the code optimization and after knowing the objectives of the code optimization, then I'm having a question like that. When to perform this optimization, when to apply the optimization techniques or the transformations, right? So for that, I'm having an answer that Optimization of the code is often performed at the end of the development stage. Make a note of that. End of the development stage. Since it reduces the readability and adds code that is used to increase the performance. At the end of the development phase or development stage, we need to optimize, right? And then the next question, why to optimize? What is optimization? When to optimize? And now my question is, why to optimize? It's an algorithm. Optimizing is an algorithm, right? And beyond the scope of the code optimization phase. And here the program is optimized. It may involve in reducing the size of the code. Where I am applying this, why I am optimizing this means at the I am optimizing the program, right? I am optimizing the program. What it means is when I optimize the program, automatically it involves in reducing the size of the code. So now I am explaining that how this optimization helps to. One point is to reduce the space consumed and increases the speed of compilation. The second one is manually analyzing the datasets involves a lot of time. It is correct because when I'm performing it manually, when I'm performing anything, even the process of compilation also, if I perform it in a manual manner, then it takes a large amount of time. And if it's done by the systematically, then it takes less amount of time. So manual analyzing datasets involves a lot of time. So we make use of softwares like Tabula for data analysis. Similarly, manually performing the optimization is also tedious and is better than using a code optimizer. So an optimization code often promotes and reusability. Make a note of this. An optimized code often promotes the reusability. And here, up to now, from the starting of this class, what is code optimization? What is code optimization? What are the objectives of code optimization? When to optimize? Why to optimize? Now, what are the types of code optimizations? What are the types of code optimizations? Before explaining these types of code optimizations, and now I need to give some advantages of the code optimization. What the first advantage of code optimization is, the intermediate code can be optimized to produce the efficient object code. That is the one advantage for using this. And the code optimization allows faster execution of the source program by making minor modifications. These two are the most important advantages for the code optimization. And here also I'm having some problems of code optimization or optimizing compilers. And the compilers which perform code optimization, they have some problems like this. That means if optimizing compilers may encounter, I explained this, the error handlers, right? At each and every phase, we can easily know what the commonly occurred errors at each and every phase itself. So if you know the commonly occurred errors, you yourself can rectify those. Just by knowing what the commonly occurred errors and how we encounter those common occurred errors at each and every phase itself. So here also I'm having some problems, some common problems. So those common problems that optimizing the compilers may encounter. And what the common problem is here is, the first one is the design of the intermediate code. The design of the intermediate code must be simple enough to optimize the code. That means if intermediate code is complex, the optimization becomes complex. So whatever the design intermediate code is there, that should be and simple enough to optimize. And what the second thing is, the grammar chooses an inefficient algorithm or data structure. If the grammar chooses an inefficient algorithm or data structures, then optimization at front end becomes nearly impossible. Make a note of this. This is another problem here. We can encounter such types of problems at optimizing compilers. And what the third one is, the optimizing transformation must be applied carefully. That means here we are applying some transformations, right? So whatever the transformation that we are applying here those should be applied carefully. Otherwise, code may become time and space inefficient. We are having the two main constraints or two main terms, that is space and time, right? Space and time. And our main goal is to generate the efficient target code. And if you are having a problem like this, the optimizing transformations must be applied carefully. That means code may become time and space inefficient. And the last problem of this optimizing compilers is the code optimization should be carried out in such a way that the time and space will not get wasted. This is the most important thing we should remember when we're applying the transformations in and transformation techniques in and code optimization. Again, I'm recalling that point. The problem here is the code optimization should be carried out in such a way that the time and the space will not get wasted. And these are the most important common problems that optimizing compilers may encounter, right? And here I explained you about the two advantages of code optimization and four problems of optimizing compilers. And now coming to the concept like and types of code optimization, it can also be called it as a classification of optimization. And it broadly classified into two types. One is a machine independent and the other one is a machine dependent. And here what the machine independent and what the machine dependent optimization is. See here, what the machine independent optimization is. Here, the machine independent optimization. Now I'm going to explain this machine independent optimization just by giving some uh, following reasons. Following reasons in the sense, I'm explaining the context with four following reasons. One thing, the code should be analyzed completely. The code should be analyzed completely and use alternative equivalent sequences of source code. If you use the alternative equivalent sequence of source code, automatically that will produce a minimum amount of target code. That will produce a minimum amount of target code. And what the next reason is appropriate. We need to use an appropriate program structure in order to improve the efficiency of the target code. And from the source program, eliminate the unreachable code. From the source program itself, we need to eliminate the unreachable code. And the last reason for this machine independent optimization. Reason in the sense I am explaining the context with four reasons, four most important reasons, right? And the fourth one is we move two or more identical computations at one place. And in the next classes, you can know what the computations are and what the transformations that we're going to apply in this code optimization and all those. And here we're moving two or more identical computations at one place and make use of the result in the sense, if for example, x is equal to y of z, right? And here what the resultant variable is x. And here I'm making use of this result instead of each time computing the expression. If you are having the same expression in the program at two or more times, then always I'm not writing the intermediate language for that line of statement. Just what I'm doing is I am instead of each time computing the expression, just I am using a resultant variable x. I'm using a resultant variable x. And these are the four most important reasons for the machine independent optimization. Why the optimization is categorized or classified into two types, machine independent and machine dependent. Here I explained about a machine independent. These are the four most reasons for machine independent optimization. What it means is here we need to improve the intermediate code to get a better target code as the output, right? So how we need to improve that? Instead of here I'm having a reason that instead of each time computing the expressions just with an resultant variable, I am reusing that. I am using that variable, that the resultant variable, instead of each time computations, performing the computing expressions, right? And here The part of the intermediate code which is transformed here does not involve any CPU registers or any absolute memory locations. One thing you need to note down this point. Here we are not involving, does not involve any CPU registers or absolute memory locations. Note down this point, most important. And now the next one is a machine dependent optimization. Machine dependent optimization is based on the characteristics of the target machine for instruction sets used and addressing modes used for the instructions to produce the efficient target code. And here, the machine independent optimization is based on the characteristics of the programming language. Once note down this, machine dependent is based on the machine dependent optimization is based on the characteristics of the target machine, and machine independent optimization is based on the characteristics of the programming languages. And for appropriate programming structure and usage of for appropriate programming structure and usage of efficient arithmetic properties in order to reduce the execution time. So we totally based on the characteristics of the programming languages in machine independent optimization. And now coming to the machine dependent, here first thing is done after the target code has been generated. And when the code is transformed according to the target machine architecture, it involves, there are not involving any CPU registers and memory locations in machine independent optimization. Here, we are involving the CPU registers and absolute memory references rather than relative references. That means it always this machine dependent optimizers put efforts to take maximum advantage of the memory hierarchy. So that's why we named it as a machine dependent optimization. And here we're having some following reasons uh, to describe the context of what the machine dependent optimization is. The first one is allocation of sufficient number of resources to improve the execution efficiency of the program. And here I'm using an immediate instructions wherever necessary. And also I'm using the intermix instructions. What the intermixing of instructions along with the data increases the speed of execution. And this is about the machine independent and machine dependent optimizations. And here the types of code optimization or the classification of code optimization should be classified into two types. One is machine independent and one is machine dependent, right? And the next thing is about what the requirements we need and what the opportunities we have, right? What the requirements we need is meaning must be preserved. That means it should be correctness. Speed up must occur on average. Work done must be worth the effort. And what the opportunities we have, programmers or algorithms or directives or intermediate code or target code. These are the opportunities that we have and the requirements that we need. These are the requirements are nothing but on resources, nothing but on resources, right? What we require, what the opportunities you have to get the meaning, to get the correct meaning, to improve or increase the speed, you need what and what opportunities. You need an algorithm or you need an intermediate code or you need a target code like that. Right? That means programmer is nothing but either it may be an algorithm program by the algorithm or by the directives. I am choosing the opportunity there itself. This is the role of the code optimization. You all know at each and every phase I'm explaining the role of the phases itself. That means at lexical analyzer, I explain the role of lexical analyzer. At syntax, I explain the role of syntax. At semantic also, I explain with the structure. And at intermediate code generator also, I explain the role of intermediate code generator. Here, what's the role of the code optimization? See, where the code optimization is placed in this structure, where the code optimization is placed in this structure, and see all of you. Initially starts with a source program or the source language, that is the input program, and then the scanner, the output in the form of an tokens, and then the parser, the output. That means in every phase should be implemented and generates the output. And the parser implementing the parser, that is a syntax analysis and generates an output in the form of an some syntactic structure. Why I'm calling that it as a syntactic structure means it is a structure or syntactic or syntax or parser, right? Whatever it may be. And then semantic analysis. And there itself I explained the intermediate code generator, and there itself I'm explaining the code generator. And finally, from the three phases like in semantic, intermediate code generator, and the code optimizer, then what we are going to generate is a syntactic or statement IC structure. What it means is intermediate code structure that is in the form of an intermediate language where consisting of some set of translation statements, that is taking as an input to the code generator, and then we're generating the target code, right, which is an efficient code. And here every phase is attached to the symbol table. Every phase is connected to the symbol table. What it means is the symbol table is a data structure, and also every phase is connected to the error handler. Make a note of this. Error handler handles the errors at each and every phase. As I already explained that we are having some commonly occurred errors at each and every phase itself. If you know what the commonly occurred errors, then you can easily encounter them, and you can modify them, and you can update, and you can generate the output, right? So the symbol table and the error handler are the two subphases of the compilers process of compilation. So every phase was connected to an symbol table along with an error handler. And this symbol table is acting as a data structure. Everything that was stored in the symbol table, right? And that means we are maintaining it as a record. We are maintaining that symbol table is as a record. So whenever we need anything, we need an information about any variable or any language statement or anything, just we go and refer at the data structure like in symbol table. There, if you refer in the records, then you can easily find out, and you can easily take the output from that, right? And this is about the role of code optimization. Where we are implementing here is, once recall the last classes, and after syntax analyzer, that is after learning about or discussing about the parsing techniques of the syntax analyzer, then the next concept I explained you is an syntax directed translation schemas, right? And generating the parse trees, and then generating and syntax directed translation schemas. Then I explained you the type checkings and type conversions and type equivalence, type systems, and all those. That means those are all comes into the semantic analysis, right? And then intermediate code generator. There also we talk about, there also when the concept about the type declarations, when I discussed about the type declarations, there also I explained you the syntax directed definitions. There also I explained you each and every three address code representations along with the syntax directed definitions. That means there we use the synthesized attributes and the inherited attributes. So that's why the representation itself, the parser representation itself shows that the semantic analysis, IC generator, and then the code optimizer. And what the meaning of the representation is, here from the intermediate code generator only, here we are applying that transformation techniques to whatever the intermediate language that we generated by implementing an intermediate code generator. So see the structure here. That's why here it was represented like this. Right? And finally, here, the output is also same as an intermediate language. Nothing differ is there. Here, after the syntax tree, we performed a semantic, right? At the semantic, the same syntactic structure we are generating. Nothing differ is there. But a small change, like a decorated, with some modifications, we structured that with some modification, with minute modifications we structured, and just we named it as a decorated syntactic structure. And here also, by performing the optimization techniques, by applying some transformations to the code, like for the intermediate code language, intermediate code generators, then finally we are generating an code in the form of an intermediate language. That's why we're calling that them as an intermediate code structure. The structure itself, it is an intermediate language where it consisting of some set of translation statements. But what we're doing here is just we're minimizing or reducing the size of the code just by reducing with the lines of the code, right? So, and how the implementation of the internal functionality of this code optimization takes place, that's where I will explain in further classes. And up to now, it's the concept about the role of the code optimization, and I'm explaining that, I'm discussing about this role of the code optimization. And finally, this IC structure is given to the code generator. Then here we generate the target language where it is an object code form. It should be in an object code form, and it is an efficient target language that we need to generate, right? This is about the role of code optimization. Role of code optimization. And then here it is about the organization. We can call it as an organization means and code optimization. And what most important things that are involved here means these are the contents of the organization, code organization. Initially with an introduction of what the code optimization is, then the classifications of optimization techniques, not the classification of code optimization, classification of optimization techniques, and then what the factors that are influencing of the code optimization, then themes behind optimization techniques, then finally optimizing transformations and examples and details of optimization techniques. These are the contents that are involved in this code optimization. That means under the code optimization, these are the concepts that we need to learn. These are all comes under the optimization techniques or transformations, optimizing transformations. So with this we are applying, with this we are improving the efficiency of the code, right? With this, by implementing these optimization techniques or transformations, we are improving the efficiency of the code. And now starts with an introduction of this code organization. Code organization means a code optimization. And here it always concerns with a machine independent code optimization. When we call the code optimization, then it can be called it as a machine independent code optimization, right? And here we're applying 90 to 10 rule. What the 90 to 10 rule is, execution speeds 90% and time in 10% of the code. And always I am saying that space and the time are the most important two constraints, two terms that we need to use here, because our output should be an efficient output. Our output, whatever we are generating from the code optimization, should be an efficient output, right? So what the meaning of this is, here it is moderately easy to achieve 90% optimization, and the rest 10% is very difficult. That means identification of 10% of the code is not possible for the compilers. It's the job of the profiler. So in general, the loops are the hotspots. And what the criterion of the code optimization? And again, I'm repeating the same things here. The semantic equivalence, as I already explained, most important issues. One is the semantic equivalence, and the algorithm should not be modified. Whatever the transformation that you are implementing, on an average should be speed up the execution of the program. And what the effort means, intellectual and compilation efforts spend on insignificant improvements. That means transformations are simple enough to have a good effect, right? So this is the main criterion of the code optimization. These are the most important things we need to remember. And see here, the profiler. There I spelled a word like a profiler. See here. I think so here. Identification of 10% of the code is not possible for a compiler. And whose job it is? It is the job of an profiler, right? And now it's the block structure of the code optimization. Block structure of the code optimization. Optimization can be done in almost all phases of the compilations. At the source code, how we perform the optimization means profile and optimize. It's done by the users. Front end. What the front end is? Front end. What consisting of the front end? Lexical analysis, syntax analysis, and semantics comes under the front end. And intermediate code here loops, procedure calls, addresses, calculations, and these are all the improvements. That means here we done the optimization. That optimization is performed by the compiler. Here only two persons are involving here. One is a programmer and another one is a compiler, right? So finally, it is a code generator, and what we're generating it is a target code. And here registers usage, instruction choice, peephole optimizations. Again, they're also all done by the compilers. That means the optimization, why we're representing this type of a block structure means the optimization we are applying, whatever the optimization techniques we are performing, not by directly we're applying all those, but at each and every phase we're doing some optimization, we're performing some optimization just to improve the efficiency. That means to get a good code, to generate the good code, right? So that's why we're having a statement like optimization can be done in almost all phases of the compilations. Initially it is done by the user and then it's done by the compilers. Initially it's done by the user and then it's done by the compilers. Is it clear? And this is the simple block structure of code optimization. And before, in the previous slide, I explained about the role of code optimization. This is about a simple block structure of the code optimization. A concept, we can also call it as a conceptual view of code optimization. That is phase by phase conceptual view of code optimization. And it is a code optimizer, that is optimizing compilers. It is an organization of an optimizing compilers. What it means is, first initially control flow analysis, then data flow analysis, then we need to perform the transformations. I think you get by seeing the structure, control flow analysis, and then we need to perform the data flow analysis, and then we need to apply the transformations. That's about the code optimizers. How the organization is carried out means initially with the control flow analysis, then with the data flow analysis, and then performing the transformations. It's an flow structure, that is step-by-step phase. From the control flows, then we need to implement a data flow, and then we need to implement the transformations in code optimization. It's done by the code optimizer. This is about the classification of code optimization techniques and peephole optimization, local optimization, global optimization. Again, the global is divided into interprocedural and intraprocedural, and then finally loop optimization. And before going to learn about the classifications of optimization techniques, I need to explain about the principal sources of optimization. And before that, I need to explain the scope of operation. First, initially, I need to explain you what the scope of operation, and then what the principal sources of optimization, and then going with this. Going with this means classification, and then what the factors of this optimization, and then the theme behind the optimization techniques, and how we are eliminating those, and finally optimizing transformations, right? These are all the things I will explain in the next class. Starting the tomorrow session or day after tomorrow session starts with the concept of scope of operation, and then principal sources of optimization, and then the classification of optimization techniques, right? And up to now in this today's session, what I explained you is, today concept is about a code optimization. It's a new concept because it's the fifth phase of the compilers. I start the fifth phase of the compilation with a code optimization phase, right? And initially I explained you what the code optimization is. I make you to understand what the code optimization is, and then what the objectives of this optimizing process, and what the objectives that we need to follow when we perform the optimization, and when the compilers optimize the process should meet the following objectives, right? That means these are the most important objectives that we need to remember from starting of this phase to ending of this phase, right? Because one to improve the speed, another to improve the time, and then the most important thing, without changing the meaning of the program. And then when to optimize and why optimization, what the types of code optimizations in between. Before explaining what the types of code optimizations, I explained what the advantages and what the problems of the code optimizers, optimizing compilers, the problems of optimizing compilers, and then the types of code optimization, machine independent optimization and machine dependent optimization, and what the requirements that we need and what the opportunities that we have. And this is the role of the code optimization. And then starting with the contents that are involved in the organization and introducing that what the code optimization is, what always it concerns with, and what the rule that we're following here. It is a 90 to 10 rule, right? And then what the criterion of the code optimization. After knowing the criterion of the code optimization, then it is a block structure of the phases of compilation. Phases of compilation, how the structure, how it is, again we can call it as a conceptual view of optimizing, conceptual view of code optimizing. That means here we're showing that at each and every phase itself we almost perform the optimization, but here we're not performing the techniques. In this concept, in the code optimization, here we're learning with the applications of the transformation techniques. But up to now, we didn't know what the transformation techniques are. That is, up to now, we didn't know the internal functionality of the code optimization. Just we know what the code optimization is, what is the purpose of doing that optimization, and then finally what it results to, right? So that up to there we know. But here, what the optimization techniques that we're having and what the transformations that we need to apply here and all those we are going to learn in this concept. And this is a conceptual view of code optimization, and this is a code optimizer, organization of a code optimizer. And directly we are not performing the transformations. Initially our input should be in the form of a control flow analysis, and then it should be converted into an, that is transformed into a data flow analysis, and finally we are applying some optimizing transformations. It's done by the code optimizer. And classification of optimization techniques, and this concept I will explain in the next class. And here one thing you all should remember, I think so. And mainly when we can say that code is an efficient or inefficient, whose responsibility is that? Whose responsibility? Only we're having the two factors here. One is programmer and another one is a compiler. Based on the two factors, we are judging that, or we're generating an output in the form of an efficient code or an inefficient code, right? So the everything should depends on the two factors. One programmer and another one is a compiler. So those those two play the most important role in the optimization.